Okay, so today we're going to be going over some implicit differentiation. Implicit differentiation can be really tricky if it's your first time seeing it, so let's just go ahead and jump right in. So we need to use implicit differentiation to solve this equation. The reason you use implicit differentiation is when you don't have an equation set equal to y. So usually when you're taking derivatives, you have a nice equation y equals x or whatever, y equals x plus 2. And then you take the derivative of everything on the side with x. But here we have x and y on the same side, so we have to use what's called implicit differentiation. So let's go ahead and solve this problem. So let's rewrite it. X plus x y minus 2x. Let's rewrite that. 2x cubed equals 2. So the notation you use when you're doing implicit differentiation is you just put everything in a bracket and you write d over dx. And that's how you know you're doing implicit differentiation. Okay. So what's the derivative of x? That's just going to be 1. And now in implicit differentiation, you actually take the derivative of both x and y. So since we have an x and y, we're going to do the product rule. The derivative of x is 1. So then you have 1 times y. Now we're going to take the derivative of y. The derivative of y is 1, so now we're just going to have x. But whenever you take the derivative of a y using implicit differentiation, you have to write down dy dx. So here we're going to have x times dy dx minus 2x cubed. That's just going to be 6x squared. The derivative of 2 is 0. And so here we go. We've taken the derivative of everything. We're done taking derivatives. Now what we need to do is solve for dy dx, pretty much, and then we'll be finished with this problem. So we can subtract this and this to the other side, or subtract or add or whatever. So now we have x dy dx. And so now at this point, it's pretty much just algebra. You use your algebra skills to solve for dy dx. X dy dx equals positive 6x squared minus y minus 1. Then you divide everything by x. Dy dx is equal to 6x squared minus y minus 1 all over x. So that's our answer here. And so you see it's actually not too bad. As soon as you know that you have to just add dy dx every time you take the derivative of a y. Let's go on to the next problem. This one's a little bit trickier. So we're going to rewrite the question. We have x squared times y plus 3x y cubed minus x equals 3. And so since our equation is set equal to 3 and there's y's and x's on the same side, we know we have to do implicit differentiation. So we're going to put everything in a bracket. And we're going to go ahead and multiply it by, we're going to take this whole equation to d dx. Okay. So since we have an x and a y multiplied by each other, we're going to have to use the product rule. So the derivative of x here is going to be 2x. Y stays as it is, so 2xy. Now we take the derivative of y. The derivative of y is 1, and so x squared stays the same. Keep your x squared times 1, and then since we took the derivative of y, we have to multiply this by dy dx. So now we're done. I'll go ahead and underline this in green. This is all from the green. Now we're going to have plus 3x times y cubed. Let's take the derivative of x first. Derivative of 3x is just going to be 3. Y cubed stays the same. Now we take the derivative of y cubed. So 3x stays the same. Derivative of y cubed is 3y squared. So you have a 3 times a 3. 9x times y squared. Now I'll go ahead and underline this in blue. This is all from the blue parts. And since we just took the derivative of y, we have to remember to write down our dy dx. Very important. Now we have a minus x. Derivative of x is just 1, so minus 1. Derivative of 3 is 0. Okay, so we're done taking all of our derivatives. Now at this point, we just have to solve for dy dx. So we notice, I'll go ahead and get rid of these underlines for now. If you notice, you have a dy dx here in this term. You have a dy dx in this term. So you want to keep these on the left side and move everything else to the right side. So let's go ahead and rewrite. We have x squared dy dx plus 9x y squared dy dx. Now everything else that isn't colored in green is going to be added or subtracted to the other side. So you have plus 1 minus 3y cubed minus, let me rewrite this, this is a cubed, minus 3y cubed minus 2xy. And so from these terms here, we can factor out a dy dx and then divide by x squared plus 9xy squared. And that should give you your final answer. Dy dx. So at this point, we're all done with the calculus. We're actually done with the calculus after this step here. This is all just algebraic manipulation. So 1 minus 3y cubed minus 2xy all over x squared plus 9xy squared. So in general, with implicit differentiation, you have to take the derivatives and then you solve for your dy dx pretty much. And that's really the gist of it. And we'll do one more problem, something kind of tricky, something different that you don't usually see very often. So we're going to use implicit differentiation to solve for sine of x squared y squared. Let me write this 2 here, x squared y squared, and that's going to be equal to x. So we know we have to do implicit differentiation because we have x's and y's on the same side here in the sign, and then we have something on the other side that's not an isolated y. So let's go ahead and write in our square brackets here. We're going to take the derivative of this whole thing. Okay, so we're going to have to use a chain rule on this sine x squared y squared. So first we take the derivative of the outside. The derivative of sine is going to be cosine. And the inside stays the same, x squared y squared. Now we're going to multiply it by the derivative of the inside. We have x squared and y squared. Well, since it's an x squared y squared, we're going to have to use the product rule. So first we'll do the derivative of x. Derivative of x squared is 2x. Then we multiply that with y squared. Y stays the same here. Now we're going to add it. Since it's product rule, you have to add the second part. X squared stays the same. Derivative of y squared is 2y. And then since we just took the derivative of y, we have to throw in a dy dx. Dy dx. Okay. So this sum here, this underlined part, is multiplied with cosine x squared y squared. And then now that's set equal to x. Well, the derivative of x is just 1. Okay. So now at this point, we've taken the derivative. No more. We're done with calculus. The rest of this is just algebra now. And so now we need to solve for a dy dx to figure out what the derivative actually is. And so we're going to multiply this in. So we know cosine is multiplied by everything. So cosine times 2x y squared the cosine times 2x squared y dy dx. 2xy squared times cosine x squared y squared plus 2x squared y dy dx. Cosine x squared y squared. And that's all equal to 1. So now we see that this term here, this green term, doesn't have a dy dx in it. So we can subtract this to the other side in order to solve for dy dx. So 2x squared y times cosine x squared y squared times dy dx is equal to 1 minus 2xy squared cosine x squared y squared. Alright. And now we just divide by this portion to solve for dy dx. Dy dx is equal to 1 minus 2x squared cosine of x squared times y squared all over 2x squared y cosine x squared y squared. And you could probably simplify this a little bit further, like creating two different fractions, because then the cosines would cancel on the second fraction, but it doesn't really matter. This is already pretty simplified. This is a good answer here. And so this is your final answer.